Welcome to this lesson, guys, where we'll be looking at exercise 11b from the Edexcel PM2 book. So stay tuned. Let's say you want to integrate cos 3x plus 1. What do? We know that cos is linked to sine. Okay, so we will consider sine 3x plus 1. And when we differentiate this, what happens? We do everything that we normally do. So sine becomes cos, and then we write this. And the chain rule says to differentiate the bracket. So what's the differentiation in here? Just 3. So what happens? Overall, it simplifies to the 3 coming here. So 3 cos 3x plus 1. Now, if you compare the differentiation to what you're trying to integrate, what do you notice? That this one doesn't have a 3 like this one. So we can say that this is the integration of this one, but we need to make a little correction, which is to get rid of the 3, okay? Because currently, if we say that this is the integration of that, well, this, when you differentiate, you actually get the 3, and you don't want the 3. You want to get rid of that. So therefore, the integration of this will be that, but to get rid of a 3, what do? You divide by 3. So it will be a third sine 3x plus 1 plus c. And this is what the correction does. So you make a little correction to make sure that you end up with what you're trying to integrate. So let's practice on these, and we'll practice a few more after that, yeah? So e to the x. So what do we consider? We're going to consider y is equal to e to the 3x, because e to the 3x is a funny one, right? All the time. So when we differentiate this, what do we get? We get dy over dx. We differentiate this, we get a 3, and then we write e to the 3x. So if you look at this and you look at that, what don't you want? You don't want that 3. So therefore, you're going to say this is the integration of that, but we are going to divide this by 3. So what is the integration of that? A third e to the 3x plus c. So if you look at this one now, what is this going to be linked with? So let me just get rid of all this. Okay. So what's this one going to be linked with? 1 over 5x plus 2. It's going to be linked by considering y is equal to ln. You're considering ln. So ln 5x plus 2. Yeah? Now, differentiate that. dy over dx. What happens? On the top, you differentiate this over the original. So therefore, the original is going to be 5x plus 2. But the top, what do you differentiate this to? Just 5. Right? Now, if you look at this, and you look at what you're integrating, what's on there that's not on there? The 5. So you're going to say this is the integration, but you want to get rid of that 5 by doing what? By dividing. So therefore, the integration of this is going to be this, but you divide by 5. So you say a fifth ln 5x plus 2 plus c. How do you get the 5? So you know when you integrate, when you differentiate ln x, right? We have that rule where we have f dash over f of x, like that, when you differentiate ln. Yeah? So that's the differentiation of just the bracket. So let's have a look at this one. So what do we need to ask ourselves? Where does sec come from, right? So what will we consider here? Y is equal to, what does sec come from? Sec squared? Tan, right? So if we look at this, now this one has a 2 here already. Can you see that none of the others, where are the, this one had no coefficient there, right? So you can do one of two things. You can either include your 2 or your value, whatever it is, in your consideration, or you can manipulate in the 2 afterwards, okay? It's totally up to you, okay? I can show you both examples. But just to make it simple, I'm just going to look at the pure trig itself, yeah? So you said it comes from tan x, right? So, but our x is going to be this bracket, so therefore 3x minus 2. So let's differentiate this, dy over dx. Now, what does tan give us, guys? Sec squared, 3x minus 2, and then we differentiate the bracket, so which is 3. Okay, so this simplifies to 3 sec squared 3x minus 2. All right, now what I was mentioning about the coefficient being there or not. Okay, if you look at this, forget the 2 that's there. We don't want that 3 there, do we? So we're going to divide this by 3. But we do want a 2 there. So we're also going to times by 2. So that is the same as dividing by 3 times it by 2 is 2/3, and then that. Tan 3x minus 2 plus c. All right, so 3 more examples for you to practice this. Let's look at this one. What are we going to consider? Y is equal to the higher power, yeah? There's no trig here, so we're just going to look at the higher power, which is going to be 3x plus 4 to the power of, no, it's going to be 3. So we're going to look at 4. Okay, so therefore dy over dx would be, differentiate this, what do we get? 3x plus 4 to the power of 3, and then we differentiate what's in the bracket in here, so therefore that gives us 3. Now if we simplify this, what do we get? We get 12, 3x plus 4 to the power of 3. Now look, we've got the bracket with the power, but we don't want that 12 there. Right? So how do we get rid of that 12 when we integrate? We will be doing what? Dividing. So this will be our integration with the power of 4, but divide by 12. So it's 1 over 12, 3x plus 4 to the power of 4 plus c. That is the integration of that. Yeah? So reminder here, when you have this power and you're trying to look for the step before that, you have to increase that power. Okay, by 1. Have a look at this one now. Back to the trigs. So sine and then 1 minus 5x. So what will we do? We'll consider what here? Where does sine come from? Minus cos. So we'll have minus cos 1 minus 5x. So when we differentiate this, what happens? So if you differentiate just cos, you get minus sine, don't you? Yeah? So you got the sign here already for minus. So you get minus sine 1 minus 5x. And then you differentiate what's in here. So what's in here? Minus 5. Now you got lots of minuses here. Okay? You got a minus and a minus here and a minus there. So overall, what will you have? Minus 5 sine 1 minus 5x. But we don't want a minus. Okay? We don't want a minus, do we? So therefore, we want to get rid of that minus and we want to get rid of the 5. So what do you think the integration of this one will be? So we want 1 over 5. This minus that's already there is going to produce a negative for us, which we don't really want to have. So really, we can take out this minus and then we won't end up with a minus overall, because the minus that the cos will produce on its own, okay, will have a minus that will multiply with this minus, giving us a positive. So we don't really need a minus. So you can always make little changes like that to get what you need. All right. So ultimately you want to divide by 5 though, right? So minus 1 over 5 cos 1 minus 5x plus c. And that's this one's integration. All right. So initially you might be looking at this and thinking of what? ln, right? However, when there's a power here, we're not going to consider ln here. We don't need to be considering ln. We will just use what we know from standardizing and take this up there. So another way to write this would be, you got the 1 over 3, so we'll write 1 over 3. And this bracket we can take up with 4x minus 2 to the minus 2. So remember that, when there's a power, you don't do ln. You'll do this process. All right? So let's have a look at this now. So this becomes our straightforward integration. So what will we consider? We will consider the power before that, right? So what's the power before that? It'll be 4x minus 2 to the power of what? Minus 1. Very good. Again, remember what I said earlier? You could include your third here, or you could just make manipulations later on. All right? But it's probably easier just to make manipulations later on. It's completely up to you. But did I do one? The last one I did, I left it out, didn't I? So how about I include it for this one? Do you want me to do that, yeah? So let me just include it for this one, yeah? So for this example, I'm going to actually include our 1/3 in the original. So you can see both ways how we do it, yeah? Right, so dy over dx, this one, guys, what do we get? The power comes down, minus 1/3, and then 4x minus 2 to the power of minus 2, and then you differentiate this, so you get a 4. Tidy this up, the 4 multiplies here, so you get minus 4 over 3, 4x minus 2 to the power of minus 2, right? Now, look at what you have. Look at what you want to integrate. First thing you'll notice is a negative. So you want to get rid of a negative by including a negative in this one when you integrate, yeah? Secondly, you've got the divide by 3, but you want to get rid of this 4. So how do you get rid of that 4? By dividing by 4. So it's going to be this with another negative to get rid of this negative and a divide by 4. So when you divide this third by a 4, it's the same as dividing by not a quarter, because the 4 will come here, multiply with the 3. So it becomes 1 over 12. Do you understand that? Yeah? So when you have a third, if you have a third as a fraction, and so you got the third already, and you want to divide by 4. Well, what do? We turn this into a fraction, put a time sign, flip these around, so it becomes 1 over 4, and we have 1 over 12. And we've divided by 4. So therefore, what we're going to do here is the integration of this is going to be, remember the minus, and then 1 over 12, and then 4x minus 2 to the power of minus 1 plus c, and that is its integration. A few more just to finish off 11b. So here we've got e to the 3x plus 1 dx. So where do we come from? What do we consider? Remember, e is that funny one, right? So we're going to consider y is equal to e to the 3. It's probably just best to write it as it is, because e is that funny one. So when we do the differentiation of this, dy over dx, what do we get? We differentiate this, bring it to the front, and then we write what we have. So what's the differentiation of 3x plus 1? 3, and then e to the 3x plus 1. Compare this to that, what don't we want? We don't want that 3 there. So the integration of this would be 1 over 3, and that plus c. Let's have a look at this one. Now, earlier on, the last example that we did, where I said when you have a power, you don't worry about ln. Do we have a power here in the denominator? No. So we are going to use ln. So what will you consider here? Consider y is equal to ln 1 minus 2x. So dy over dx will be differentiation of that. Yeah, good. So it's minus 2 over 1 minus 2x. Yeah, so that's the differentiation. Now, if you look at this and what we have, we don't want, first of all, a 2 there. So we're going to divide by 2. And we don't want a negative there. So we're going to divide by minus 2. So therefore, what's the integration of that? It's going to be minus 1 over 2 and that. ln 1 minus 2x plus c. And that's the integration of that. Right, this one. What will we consider for that one? So y is equal to, we'll go up a power, right? So what do we have? 4 minus 3x to the power of 6 dy over dx. So therefore, what do? 6, 4 minus 3x to the power of 5, and then we differentiate that, which is minus 3. Simplify this, what do we get? 6 and minus 3 is minus 18, 4 minus 3x to the power of 5. What don't we want here? We don't want the minus 18. So we're going to divide by minus 18. So therefore the integration of this would be minus 1 over 18 and that plus c. Now one more left, sec 3x, tan 3x. What differentiates to sec tan? Sec. So we are going to consider for this one, y is equal to sec. And it's going to have a 3x. So it's going to be sec 3x. And when we differentiate that, so dy over dx, we get, what do we get? We get the 3 at the front. So 3 and we get sec 3x tan 3x. But we don't want that 3 there, do we? Yeah, because that doesn't have a 3. So that our integration is going to be this, but divided by 3 or times by a third. So therefore, integration of this is going to be 1 over 3 sec 3x plus c. And that should fully complete exercise 11b. Hope you enjoyed that one, and I'll see you in the next lesson.